Hello everyone. In this international conference on chemical matter on University of Ouargla Algeria, my name is Tayeb Halais, Wissem, PhD student at University of Galma. So the topic of my presentation today is calculation of ferromagnetic electronic and optical properties of 3D vanadium magnesium. The outline is as follows. I will to present small introduction, then I will talk about the method of calculation, next I will show the results, finally I will give a conclusion. Magnesium oxide is a non-magnetic compound stable in the rock salt phase. It can be employed in catalysis, microelectronic, and different other applications. We choose the 3D transition metal vanadium to see their effect in the structural, electronic, magnetic, and optical properties in our oxide. So, the calculations were done using DFT. The local density combined with TB-MPG utilized for the exchange correlation potential implemented in the Wayne-2K package, which ran two results. For the structural properties, the crystal structure of binary and ternary MgO compound were shown in figure 1. The volume optimization was carried out for the steady compound and it's shown in figure 2. The equilibrium energy were observed after volume optimization and the latest constant calculated are shown in table 1. The results indicate that the compound favors the ferromagnetic state as stable configuration. In order to determine the electronic properties, we start with band structure. Figure 4 represents the band structure of the majority and minority spin channel. We can see in this figure that the spin up is a semiconductor with direct band gap equal to 3.21 electron volt, while the spin down is an insulator with direct band gap equal to 7.75 electron volt. So the steady compound is a ferromagnetic semiconductor. The result of energy gap illustrated in table 2. Magnetic properties. The intermagnetic moment value are given in table 3. The magnetic moment of MgO is 0, but after doping with the transition metal, the magnetic moment were created in our ternary compound, so the vanadium transition metal is contribute in create the magnetic moment. The optical properties are straight correlated to the electronic band gap of semiconductor and characterizing the interaction of electromagnetic radiation with the material. Figure 5 represents the imaginary part of the electric function epsilon 2 and the absorption coefficient in the range of 0 to 30 electron volt. The results show a good absorption in red to visible spectrum region. This result implies that Mg-doped vanadium system seems to be a good candidate for optoelectronic device. Finally, we believe that the work will bring valuable knowledge to field and will seem as good for future research. Thank you for your attention.